11-2 or 11-3? 11-3, and this is geometric sequences, okay? So we learned about arithmetic sequences, and a geometric sequence is one that looks like this. And at some point you guys are going to get whiteboards and do some practice here. 2, 6, 18, 54. Who can tell me what's happening in this sequence? What's happening in this sequence, Ethan?
It's going up exponentially.
It's what?
Going up exponentially.
Not exponentially. Exponentially is when you raise to the power. Go ahead, Max. Right, you're timesing by 3, okay? Multiplying, not timesing. So if I time 2 times 3, right? 6 times 3. 18 times 3. So the next one would be what? Times 3, what would go in the next space? What's that? 162.
Yeah.
Anyway, okay. And here's another type of geometric sequence. What if I had that one like this? 2, 1, 1.5, what would come first?
0.5.
Yeah, that's, no, not 1/4, okay? What am I doing to the previous term? Well, very good, Kevin. Multiplying by 0.5 or by 1/2, or you can say it's dividing by 2, right? So I would say multiplying by 1/2, okay? Times by 1/2, times by 1/2, times by 1/2. That's what I'm trying to write. What would be the next term in this sequence? 1/8, okay? So a geometric sequence is one in which you're multiplying something each time by something. The way it's defined is, this is another formula. A sub n is equal to a sub 1 times r to the n minus 1, okay? R has a name, it's called the common ratio. Common ratio, okay? And a sub 1 is the first term. So R is what you're multiplying by each time. For instance, in this first one, if I want to find the 5th term, which would be this one right here, I would go a sub n is equal to the first term, which is 2, times the common ratio. What's the common ratio? What am I multiplying by each time? No, this one. 3, right? Times 3 raised to the 5 minus 1 power. So if I want to find the 5th term of this sequence over here, and you have to do things in the correct order. So you have to go I should have written a sub 5, right? A sub 5 is equal to the first term, which is 2, times 3 to the 4th. So don't do this, which some people did in the other class. They multiply 2 times 3 and then try to raise it to the 4th power, because that's the wrong order of operations. You have to take 3, raise it to the 4th power, and then multiply that by 2. So it's 2 times 3 to the 4th power, I think is 81, okay? And 2 times 81 gives you 162, which is what I got over here for that term. Yes?
Yep.
Isn't that sick?
Dope.
That is dope, man. Okay. So the way you find R, okay, R is equal to a sub n plus 1 over a sub n, okay? In other words, I can take any 2 terms and divide one after by the one before it, and I will get the common ratio. So for instance, in this case, 6 divided by 2 is what? 3. 18 divided by 6 is 3, because the opposite of multiplying is dividing. 1 divided by 2 is what? 1/2. That's my common ratio. See that? Okay? So, now, guess what time it is? It's time. It's Winchell Mahoney time. It's Winchell. You never heard that, did you? Here we go. So, are we recording? We're recording. We're back to recording. So, here's we're live, baby. Okay. So I have a sequence that's going like this. 4, 20, 100, 500, 500. Find R. Find R. Go ahead. Piece of cake. I don't think you even have to. That's right. That's right. That should take you 2 minutes. Why should take you 2 seconds? When you get there, when you get there, Sophia. Yes. Emily, where's your answer?
Oh, I know.
It's fine. I don't need that. So now,
How do you find that?
using the formula, okay, A sub n is equal to A sub 1 times R to the n minus 1, okay? Now write the formula for the nth term. Find the
Should be A sub.
nth term, okay? So in other words, find a formula for A sub n, okay? Should take you another 5 seconds, okay? Find a formula for the nth term, okay? That is correct, David. That is correct. No. Okay? That is correct. No, Skylar, you don't, like I said, don't multiply those two numbers together.
Oh,
Okay?
they mean you're finding
Uh,
four.
Where's yours? Where's yours,
I mean, there's a.
David?
Whatever, I know what it is.
Where's yours?
Oh, I gotta write it.
Do we not know then yet?
No, it's four.
Yes,
Gotta put the
okay,
numbers.
yes.
It is a leader amount of things like that.
Yes.
And you gotta put
Okay,
I don't know, I wasn't here.
N is 4.
just started today.
Oh.
I was A sub 1 is 4.
That's right. No, Kevin? Caleb, what do you got? I mean, Kaden, what do you got?
What would he gotta write?
I need a bit more
learning.
Okay. Okay, so, say it's going, so here's a tricky one, okay? So here's another sequence. So this formula, A sub n is equal to A sub 1, which is 4, times 5, which is R, raised to the n minus 1. That's the formula. So if I wanted like the 20th term, I would plug in 20th, okay? And so on and so forth. How about this one? 3, negative 6, 12, negative 24. Find A sub n, okay? Find A sub n. What am I multiplying by each time? That's what you're trying to figure out, okay? Ready? To find R, I just divide this by this. So R, do you guys all get R is negative 2? Negative 6 divided by 3 gives you negative 2, or 12 divided by negative 6 gives you negative 2, or negative 24 divided by 12. And A sub 1 is 3. So A sub n is going to be A sub 1, which is 3. I would put this in parentheses, times negative 2 to the n minus 1 power. Okay? So now we're going to find some terms. Okay? So see if you can, on your own, okay, find the, there we go.
This equation.
Yep, no, find the eighth term of this. 3, 6, 12, 24. Who do we appreciate more? Yeah, that would work. Find the eighth term of that, okay? Wait, wow, how'd you do that so fast? Skylar? Okay. I barely even put down.
Why so many
Yeah.
people cheating?
That's correct. Skylar, very good. Okay. Niet. That's a no. That is correct, Joe Data. No, Ben, I think you did something.
I subtracted.
That is correct. You have to figure out what the answer is. So what is that answer? Good. Yes, Katie, that's right. That's right. Whoa, that number is too big.
But if you actually.
So probably what you did, Fee, is you multiplied 3 times 2 and then you raised it to the 7th power. Can't do that.
Oh, okay.
Okay? It should be positive, young man. That, yeah, you didn't find the answer though, Max.
And I was a.
Where's your bird?
Mr. Leader, I don't think I did this right.
What are you doing?
Mr. Leader, did I correct? Right in the I don't think so.
Yeah, but I don't.
That
Is that
is.
3 to the 7?
No, 3. No, yes. Okay.
Wait, Mr. Leader, I need some help.
Okay, yes.
So you raise 2 to the 7th power and then you multiply.
Stop.
Why 2 to the
Okay.
7?
Stop. So why? So you have to go and see if you can figure that one out. So you have to be careful. Whatever. Oh no, you don't have to be. Yeah, you have to. So you have to take whatever the multiplier is and put it in parentheses, raise it to a power, and then you're going to get an answer.
Is it a big number, Mr. Leader?
Is it a big number? No, it's a pretty small
Are
number.
you kidding?
That is correct, Emma. Yes, that is correct.
Oh.
You cheated.
He didn't cheat. No, he is. Who's cheating?
You.
You can't cheat on this.
This?
That is correct, that is correct. Yes. What do you get, Ethan? You don't know.
It's a small number?
Negative. It's negative. Yes, that's right, Steve. What do you get, Tristan? Sophia, yes, that's right. Gabe, D, that's right. Caleb, that's right. Hayden, what are you doing? Drawing an invisible ink over there? Grace, where's your answer? Okay, work faster. You're too busy working on your cell phone. Okay. Very good, Dale. Hey, where'd you get that marker, Katie? I want to have it. All right. Now, David, where's your answer?
You did.
Oh, you did do. Okay, so if you didn't get that, so if I were doing this on a calculator, I'd say 64. Then I go parentheses. You could even do it all like this, negative, and then I'd get my fraction button, which is right there. So you have to do 1. Yeah, you can do it. You can do 1 divided by as well. Okay, 1 divided by 2. Arrow over. Close that parentheses, and then I could raise that. These are really nice calculators because they put everything where they're supposed to be, right? And then I could just go raise to the 9th power, and then you just go over, and then you hit enter, and it gives you negative 1/8, which is negative. If you didn't want it as a fraction, you hit that button right there, and you get negative 0.125. See? Isn't that amazing?
Yeah.
Isn't that amazing? Isn't that amazing? Okay. You ready for more? Okay, so here's another formula that I'm going to give you. Okay? S sub n. S, yeah, you should probably write this down. S sub n. What? Yes?
Are you gonna have all these equations on the finals too?
Yeah, I'll give them to you if you need them. Okay? So S sub n, this is the sum of, so we have another formula for the sum of an arithmetic sequence, sum of a geometric sequence. So some smart guy, if you're interested in the proof, you could look it up in your book, okay? But the sum of a geometric sequence is this. It's equal to a sub 1 times 1 minus r raised to the n over 1 minus r. So this looks kind of confusing. I'll show you what it means, okay? So, for instance, example, okay? Find the sum of the first 7 terms, okay? 7 terms? 7 terms. 7 terms. 7 terms. Okay? So of this sequence, 3, 15, 75,
Easy.
75, 375. Who can tell me what R is in this case? R is 5. Does everyone see where we got R is 5?
Yep.
What's A sub 1? 3. So now I do is plug and chug into the formula. Okay? So plug and chug S sub, we'll call this S of 7 or S sub 7, meaning the sum of the first 7 terms is equal to the first term, which is 3, 1 minus 5 raised to the 7th power, close parentheses, divided by 1 minus 5. Okay? You can do a little bit of algebraic simplification. What you cannot do is go 1 minus 5 and raise it to the 7th power. So you have to follow the correct order of operations. Fortunately, your calculator is pretty good at recognizing order of operations. But this is the way I would do it on my calculator. I would go parentheses 1 minus 5 raised to the 7th power, okay? And then I would multiply that by, what would I multiply that by? Whoops, I think I put my parentheses. You gotta be careful because this parentheses needs to be over here. That's better, okay? 1 minus 5 raised to the 7th power times 3, okay? And then I'm going to divide that answer by what? Negative 4, okay? See what I did? So I just want to make sure I'm doing that. So I did the parentheses first. Then I'm going to multiply by 3 because it doesn't matter which side that 3 is on. And then 1 minus 5 is negative 4. Then if I hit enter, I get that the sum of the first 7 terms of that sequence is 58,593. Isn't that cool?
Yes.
It's kind of cool that you can find the sum of a geometric sequence using that formula. If you're interested in where that comes from, I'd be happy to do a derivation of it. But
I don't know what that means.
You should. That sounds.
you figure out where the formula comes from. But I'm afraid
No, let's not.
I don't. So you guys are going to try this now. So I'm going to take this formula so you can have it. Place, capture, new page. Here's the formula. Okay. And I'm going to say, find the sum of the first 9 terms. Okay? So, find, you try. Find the sum of the first, there's more after this, 9 terms of this one. Negative 5,
Yes.
10, negative 20, 40, dot, 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 dot. Okay? Let's go through it. Okay? So a sub 1 is negative 5, right?
Yep.
1 minus, what's R?
Negative 2.
R is negative 2, right? So you have to kind of do this. Negative 2 raised to the n, which is what? 9, okay? And then divided by 1 minus negative 2, correct? Okay? So, yeah, you can't just add 1 plus 2 and raise it to the negative 9 because you'd be messing up with the order of operations. So this is what I do. I would take my calculator, I would go 1 minus negative 2 to the 9th. So you can do that with your calculator. It's clear, okay? 1 minus negative 2. I'm going to put this in parentheses. Negative 2, okay, parentheses, raised to the 9th power, right? So that's going to give me what's inside that parentheses. Then I'm going to take that answer, okay, I'm going to multiply it by negative 5, right? Then I'm going to take that answer and I'm going to divide by what?
3.
Divide by 1 minus minus 2, which is 3.
Minus negative 2.
minus negative 2, which makes positive 3, and I get negative 855. That's what you should have got. Okay? Negative 855 is the correct answer. Okay? Whoa! Was I recording during this time? Oh, I was. Good. Okay? Now that you have that mastered, okay? I know you don't. We're going to pause for a couple seconds, okay? You need a refreshment break. Let's stop. Now I'm recording it. If I have something like this, 3 plus 6 plus 12 plus 24 plus 48, this is called a geometric, not a sequence anymore. Anyone remember what it's called if I'm adding them together? It's called the geometric series, okay? This particular one is called a diverging geometric series, okay? Meaning the limit is, what's going to happen to this thing is I added numbers forever and ever and ever, okay? Kevin? What's going to happen to this thing is they kept adding numbers? It's going to keep going forever. So the limit is sideways 8. What is sideways 8?
Infinity.
Infinity. So its limit is an infinite, okay? And R, in this case, the absolute value of R is greater than 1, okay? But, and you can't really find, you can find the sum up to a point, but you can't find the sum of that because it goes on forever. But believe it or not, if I have something like this, hey, this is interesting, I think. Anyway,
I think it's interesting.
if you have something like this, 2 plus 1 plus 1/2 plus 1/4 plus dot, 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 dot.
Plus 1/8.
Okay, plus 1/8. This, where the absolute value of R, meaning the multiplying thing that I'm multiplying by, whether it's negative or positive, it is less than 1. This is called a converging geometric sequence. Geometric sequence. And believe it or not, this thing, even though I keep adding numbers to it, plus 1/8, plus 1/16, okay, it has a finite, it has a limit, it has a value. So if I kept adding things forever and ever, I would get a value. What is that value? Anyone want to guess?
Infinity.
It's not infinity. What? I'm gonna draw a picture of it. Here it is.
Is
Okay.
it gonna be a triangle?
No, it's gonna be a rectangle. So here's a rectangle. Say I were to make this rectangle. Here's a rectangle. Okay. So say this rectangle is a 4. Say this dimension is 4, and this dimension is 1, even though it doesn't look like it. So here's a rectangle. I'm going to take half of that rectangle. What is the area of this rectangle? The area of this is
2.
right. This is 2, right? Now I'm going to take this half over here, right? And I'm going to add half of this rectangle. What's the area here? 1. Do you understand that?
Yeah.
Okay. How much would half of this rectangle be? I'm going to add a half. See what I'm doing? I'm doing this right here, right? I'm adding a half. Now I'm going to add how much? 1/8, right? Now I'm going to add 1/16. Now I'm going to add 1/32. Now I'm going to add 1/64. Now I'm going to add 128. Now I'm going to add 256. If I kept going forever, can you go sit in the hall, please, where you're not disrupting the class?
I was just
Okay?
trying to.
Talk while
I was
I'm
asking
teaching
a
you.
question about.
Okay, so keep your mouth
Yeah.
shut.
Okay, I'm sorry. I was just confused.
So altogether, what would be the area of this rectangle? It's 4 by 1. So if I added these up forever and ever and ever, this is going to approach a finite limit, which is equal to 4. Seems weird, But if I keep adding things together forever and ever, infinitely smaller pieces, I would get to a value, and that value is, in this case, 4. And here's the
I don't
formula.
understand how that works.
Yes?
Wouldn't you never actually get 2, 4?
Yeah, but if you, when you talk about getting limits, you say you actually go to infinity, okay? So you actually go on forever and ever and ever, and eventually it approaches that limit, and that limit is,
That is actually really cool.
okay? I mean, think of it, if you did 1,000 times, it would be so close to 4, you couldn't tell the difference, okay? Right, because already, if I added these up, I'm already at 3.5, 3.75, 3.9 something, right? 3
Oh, I
so
get it.
I'm already at this. So if I kept adding pieces, I would get to 4. There's a formula for that. S sub n of an infinite, so I'm going to write it like this. It's a very simple formula. It's just a sub 1 over 1 minus r, okay? So this is the formula for the sum of a geometric converging, you can impress your parents. We learned how to find the sum of a geometric converging series. Okay, series is different than a sequence. With the series you're adding. So in this case, what's a sub 1? 2. What's r? What's r? 0.5, right?
Oh, yeah.
So I'm 1 minus 1/2. So I get 2. What's 1 minus 1/2?
1/2.
1/2. What's 2 divided by 1/2?
4.
4. Okay? There you go. There's the limit. Okay? Isn't that
Get
cool?
Hashtag insane.
Isn't that cool? Let's do a you try one, okay?
Oh,
Last one. So, you try last one, okay? You try find the sum, okay? We're gonna start with 3, then we're gonna go to, what should I go to?
9,
10.
1. Then we're gonna go to 1/3. And we're
Oh,
gonna
that's
go to
easy,
1/9. Okay? Go ahead. See if plus dot forever. Okay? Hold on. I don't want to put it up yet. Okay? I'm gonna pause. Whoop. Pause. Right?
And 9 out of 2.
But so dividing by a fraction is same as multiplying by the reciprocal, okay? 3 times 3 is 9, divided by 2 is 9 over 2, which is exactly equal to 4.5, okay? That's it. If you got like 4.3, I would take points off, yeah. No, I take points, because it's exact. This is exactly the limit that it's gonna throw. Not like, what? Oh, if you left it like this?
Yeah.
No, that's fine, that's fine. But if you put like 4.4 or 4.728, that's wrong.
Yeah, go get a drink of water.
Per dollar.
For what?
I thought you said you can
$1?
session for free.
Oh, yeah, go ahead.
Yes.
Let me go.